Hello all, so let's continue with the lecture number 2. So we'll obviously start with perceptron, but in last slide or in last lecture, what we saw is that we saw the drawbacks of MP neuron on some logic gates, right? So I'm just trying to just revisit all those drawbacks, right? You already know that what are the drawbacks, but I'm just trying to revisit those drawbacks on the real life example which I cooked up. So here is a simple example which shows that whether you should read an email or not. So there is some, let's say he or she wants to design some Python program or some application, that whether we should read or the email or not, because he or she might be on some top company position and he or she receives a lot of emails daily. So which one he should read? Let's say this is a data set for that. So I am just taking 2D example, that is two features, so that I can plot here and explain you. So there's two features, x1 and x2, that is whether the author is known and the email is long or not. Then we'll decide either 1 to read it or 0 to not read it. So depending on, I'm just cooking up this so that it is like an XOR problem. So it's just a simple MP neuron, and we already know that we have to encode this theta, which is also called bias now. I'll call bias from now, and the output is y cap. So whether we have to read this email or not, this is a simple classification problem, and let's say we hand coded our bias here as b equals to 2, right? So what are the drawbacks? That firstly, here we have fixed slope, we can't change the slope of the line because we don't have weights here, right? The line will be like x1 plus x2 greater than b, right? So it will always be a line with fixed slope of -1. So we'll see that very first drawback is a fixed slope. Let me just clear the stuff and then animate so that you can see it. So it's like first is like fixed slope of -1, right? So if you'll see all the lines, we have fixed slope. This all lines are parallel. You can see that. Also, the one more drawback is that this is just like a graph that I plotted here. Okay, so you can consider it like an origin here, and then 1 0, then 1 1, and here it's 0 1, like that. But just a for visualization purpose, I just draw this, and don't mind about this colors, right? It's just for visualization purpose. It's nothing like red is 1 or 0, nothing like that. So, and the other drawback is we can just have distinct values of b. So here we don't have much flexibility here because we just have one parameter. So we can just change the line in one particular, we can't change intercept like this. If we want here in between, we can't do that, right? We have just fixed number, and fixed numbers are b equals to 2 or 1 or 0, like this, right? Based on whatever hand coded threshold we decide, right? So this is the XOR problem, because if you will see here, this is the red point and this is also red point here. So no line can separate these two red points. We need some non-linearity like this, right? And these are green points. So we need some non-linear boundaries in order to classify this, right? And that's why MP neuron is not useful in such cases where we have XOR kind of problem, which is called XOR problem, which I already discussed in last class while discussing XOR gate, right? And that's why it's named as XOR problem. So this is just to recap the MP neuron with some real life example. And we already saw this slide that Perceptron is our rescue. So what happened in Perceptron now, that it is more general model, of course, and the best thing is we have now real inputs. It's not like we have just ones and zeros. We have real inputs. We'll see the example on next slide. Then moreover, inputs are weighted. So as you can see, we can give weights to the inputs now, right? Also, the most important thing that we will discuss in this lecture is we have the algorithm to learn these weights, right? And then we'll answer this question after learning algorithm, that whether we are able to implement nonlinear functions or not, right? So let's continue step by step. Firstly, from now, if you can see here that we have weights. So let's say I have two features, x1 and x2. Then I'll be having w1 x1 plus w2 x2, right? And so on, like let's say two features should be greater than b. Now what I will do is I'll take this b this side, so it will be minus b plus w1 x1 plus w2 x2 should be greater than 0. And now what I will do, I'll write minus b as w naught here. If you can see here, this is nothing but minus b. And I will write x naught, which is 1. So it doesn't matter if you'll write x naught. So this is x naught that you can see here. So this is just to make x naught, w naught x naught plus w1 x1 plus w2 x2, and if you have n number of inputs until wn xn, right? But we'll stick to 2D input here so that we can visualize it nicely, right? So this is really simple. So now our w consists of w1 up to wn including w naught. So it will consist of w naught to wn, right? It's a vector. And our x will also consist of x naught up till xn, or you can just write x naught as 1, doesn't matter, right? So from now on I'll just focus on w and x, and w consists of everything including bias. So let's see ahead. Simple real life data. Now you can see whether we'll like a movie or not. So I'm just taking two features right now, which is movie ratings. Let's say it's IMDb ratings, and the ticket price in USDs, that is US dollar, and like or dislike, 1 or 0. So the general algorithm says that just initialize W's and B's, or let's say I just included B into W, right, as W naught. So let's just initialize. So in short, we have two parameters, W and B, but I'm considering now both into one W. So initialize our parameters, then loop over all the data points, that is this one. So it's not like we have to go sequentially. You can just take, right, any shuffle and then take sequentially, doesn't matter. So then there is compute some loss function. So this is the idea in general learning algorithm, right? That so I didn't introduce loss function yet, but we will see later in detail what loss function actually is. But I will brief you here that let's say firstly we are initializing w's. So with initial parameters we will get some line based on w's and b's. It will be some slope and some intercept. So let's say we are getting this line. Now if we consider very first point, then we'll see that it is positive. Let's say, sorry, it's 0, right? So let's say it is 0. Let's denote it by zeros and positives as cross. So it is cross, and we'll see that what this line is predicting. Let's say our line is predicting as all data points on this side as cross, but this comes as 0. So this is not good. So what we'll do, we'll say that it's not correct, let's rectify it. So there is something called loss function, which just takes the difference between the actual value and the predicted value that we get initially, and then we update based on the loss that we get, and that's why loss function is used. So we update our parameters, that whatever we initialize, obviously we start with random, so it's always not good and not correct. So we'll iterate through this, and we'll update our w's and b's and loss, and we'll continue this until satisfied, right? So this is general recipe. We'll see actual loss function, its name. There are different types of loss functions. We'll see everything thoroughly, but this is just in general, we'll follow this. Now let's see the particular one for perceptron. So for that, now you can see that, just a footnote, that I included 0 here. So w naught, that is bias, is here. That's why you can see 0 here and not b or theta, right? This is just an mathematical form of decision that perceptron makes. So let's say the inputs, that is the features x1 and x2 with labels 1, this is 1, belongs to some set p, and similarly all the inputs with label 0 belongs to some set n. Then obviously we'll start initializing randomly. So right now I'm not writing b, you can notice here, because I included b in w's. Now this is a vector totally, that's why it's bold. Now while not satisfied, so until not satisfied, we'll pick random x. This is what, so from all this data points, from all these data points here, right, let's say we have n number of data points, Then what we will do, we'll pick any random x. Then we'll see that we know that what any random x belongs to, because this is a data set and this will be provided. So we know this column and we can see that, let's say we pick this randomly, then we know that this is belonging to class 1, that is positive. So if it belongs to positive, but because of the random initialization of our parameters w, if we are getting that it is belonging to negative class, because when it belongs to negative class, when this summation, right, will be less than 0, you can see from here, then it's wrong, because actually it is in positive class but we are getting negative. So there is a need to update our parameters that we randomly initialized, right? And similarly, for the vice versa case, that if our actual x belongs to negative class but it shows that our random initialization shows that it is positive, we will update w. So this is like an assignment operator. It's like we are adding in the old w something x, that is our whatever input, and we are assigning it to again w, which let's say we call new. But in programming language we can just write like this, that this is an assignment operator, right? This is again the assignment operator, that is we are decreasing it and then assigning to w. But the question is, why we are doing this and this? Why just not decrease here or multiply or whatever? Why we are just doing this? Any reason, any proof behind it? So we'll see the proof in next slide. Okay, I'll just not go into very mathematical detail, but I'll give a brief intuitive proof with a little mathematics that you will conclude, or that will make you understand that yeah, whatever we are doing is correct mathematically. Then I'm just showing you right now, after clearing the screen, that how it works. So it just start with any random points. We pick any random points and try to adjust it. Let's say here we have 14 points. You can see the 14 on the top when the animation stops. So we can just say that it will continue and then stop some after it's the data is separable, right? But what if my red point lies here somewhere? Then what it will do, it will try to have lines from here, and then all these blue points are misclassified because actually they are blue, but when we'll have line here, they will be red, they will be classified as red. So the conclusion is that in Perceptron, the perceptron learning algorithm or the perceptron works only when the data is linearly separable. So the question was, like, what about non-linear functions here? So the answer is, we can't separate using single perceptron the non-linearly separable data. We'll see, maybe multi-layer perceptron can do that. Multi-layer means, like, we'll see, I didn't introduce yet the concept. It's like we'll use so many perceptron and then we'll connect to other layer once some other perceptron and so on, right? But we'll see whether this will work, and we'll also see that how we'll proceed from here to introduce non-linearity using sigmoid neuron. So there will come with activation function. Some of you might have heard about all of this if you know deep learning basics, but if not, we'll continue thoroughly. We'll focus, our focus is that this course is for all the audience, whether they are beginners, intermediate, or whatever. So we'll continue from this point. Stay tuned. I hope you enjoyed it. Thanks a lot.